Hello guys, welcome to the third episode of Relations and Functions. In this video, we're going to be discussing about functions. So what exactly is a function? Let us try to understand this using this example. Imagine you have a machine. Imagine you have a machine. So this machine, imagine this is a sugarcane juice making machine. Okay. So for every single input you give, it gives a specific output. So this machine, so if you put suppose sugarcane inside this machine, you get sugarcane juice outside. So in the exact same way, function is also a type of machine. So we give a special input in the form of numbers. This function processes those inputs and produces a specific output. So output. So what are all the possible input which you can give? Those inputs are called domain. So what are the possible inputs you can give to this function is called domain. And what are all the possible outputs you can get from the function by processing it? We call it as range. So I hope you have an idea of this. For example, if we take f of x as, imagine we define f of x as x square, x square. So if I put x equal to 1, x equal to 1, so let us try to process that function. So f of x equal to x square. So if I put x equal to 1, f of 1 square equal to 1. So my output I got it as, so my output I got it f of 1 as f of 1 equal to 1. Now if I put x equal to 2, my f of 2 is equal to 2 square is 4. So f of 2 equal to 4. So it's like that. It's like a machine which processes numbers and gives out specific output. So function is basically a special type of relation in which every single input has a specific output. So in order for a relation to become a function, there are two important criteria. So first criteria is every input should have an output. Should have an output. So this is the first criteria. So every input you give, you should get an output. So this is the first criteria. And the next thing is every input has only one output. Every input has only one output. So what number you give, it should be having only one output, and that's unique for that particular input. So that is the second one. First one is every single input should be having an output. So this is basically criteria for a relation to become function. So let us try to understand functions using this particular example. The textbook I'll be using here is Ncert textbook of 11th standard. I'll put the textbook link in the description. You can go and download it for free. So here I have, let n be the set of all natural numbers and r, so the relation r be defined on n such that r equal to set of all x comma y such that y equal to 2x, where x comma y belongs to natural numbers. We are supposed to find the domain, range and codomain of r. Is this relation a function? So let us try to find the relation first. So our relation is given as set of all x comma y such that y equal to 2x and x comma y belongs to natural numbers. So basically our y is 2 times x. So if you want to write this in reducer form, it's going to look something like this. So our natural number starts with 1. So if I put 1, so x equal to 1, y becomes 2. So comma 2. If I put x equal to 2, my y becomes 4. If I put x equal to 3, my y becomes 6. So on. So if I put 4, it becomes 8. And then if I put 5, it becomes 10. So on. So this is my relation. Let us try to represent this relation in arrow diagram. So this is our first set n, and this is our second set n. So we have 1 2 3 4 5 6 7 8 9 so on. Here we have 1 2 3 4 5 6 7 8 9 10 11 and so on. So let us try to check whether this relation is a function or not. So first goes with, so 1 goes with 2, 2 goes with 4, 3 goes with 6, 4 goes with 8, 5 goes with 10 and so on. So as I told you before, in order for a relation to become a function, every single input should be having an output. So 1 has an output, 2 has an output, 3 has an output, uh, even 6 has an output, so 12 I didn't write. So we can still extend and go on. So every single input has a specific output. And also every single input has one and only one output. So there is no two outputs for one input. So from this I can say this following a relation is a function. So yes, it is a function. Yes, it is a function. And then they're asking, supposed to find the domain, codomain and range. So as I told you, domain is all the inputs which you can give. So what are all the possible inputs? 1 2 3 4 5 6. Every single natural number could be taken as domain. So our input or domain is domain is set of all natural numbers. Our range is, you can see our range is 2, 4, 6, 8, 10, so on. So set of all even natural numbers. So set of all even natural numbers is our range, and our codomain, as I told you, it's the second set always. So codomain is set of all natural numbers. So this is the answer for the 10th one. So the next thing is the function from a, so function f from a to b is denoted by, so this is how we denote this thing. So we call this as function from a to b. So this is how this is denoted as. And the next one is a function which has either r or one of its subset as its range. It is called a real valued function. So basically, so let us try to understand this using an example. So this is our function f of x, this is our domain which is input, and this is our range, isn't it? So this is our domain and this is our range. So if the range, so what output you get, if the output is either r or one of its subset of r, we can call that as real valued function. So the next one is if domain and range both is r or the subset of r, then it is called real function. So in this case, only the range was r or subset of r, whereas in this case both domain and range is r or subset of r. So if both domain and range is a real number or the subset of a real number, we can call it as a real function. So this was the note which you need to notice. Now let us try to solve the example 12. So let n be the set of all natural numbers. Define a real valued function f from n to n by f of x equal to 2x plus 1. So you're supposed to use this and complete this table. So first we have x equal to 1. So our input is x equal to 1. For that, for what function? F of x equal to 2x plus 1. So put x equal to 1 in here. So 2 into 1 plus 1. So 2 plus 1, which is 3. So answer for the first input is 3. So if you give x equal to 1, you'll get your output as 3. So next one is x equal to 2. So put x equal to 2. So this becomes 2. So 2 2s are 4. 4 plus 1, 5. So put x equal to, so this is 5. So x equal to 3. F of 3 equal to 2 into 3 plus 1. So 6 plus 1, 7. 7. In the exact same way, try to solve the rest of the problems. So answer for this is going to be 9. This is going to be 11. This is going to be 13. And the answer for the last one is going to be 15. So this was all about the example. Now let us try to understand some specific functions and their graphs. Some functions and their graphs. Now these functions are used widely across the relations and functions and across different fields in mathematics. So the first one is identity function. So identity function is define function from real number to real number for x belongs to r. So x belongs to real numbers. Y equal to f of x equal to x. So this is our function, and this function is called identity function. Now the domain of this function is r, whereas range is also r, which is, so r stands for real numbers, which is all possible numbers. So if you want to represent this function in the form of graph, it's going to look something like this. So this is our x-axis, this is our y-axis, this is our x dash, and this below is our y dash. So this is our origin, 1 2 3. So just if you want to find a graph and you don't know how to do, just go to the function. So our function is y equal to f of x equal to x. So it's basically y equal to x. So for every value of y or every value of x, it's gonna be equal to y. So suppose if I put x equal to 1, my y is also gonna be equal to 1, because y and x basically are equal. If I put x equal to 2, my y is also going to be equal to 2. If I put x equal to 3, y is also going to be 3. So if I represent this on the graph, so x1 y1, so this is 1 comma 1, and this is 2 comma 2 and 3 comma 3. In the exact same way, if I put x equal to minus 1, my y is going to be minus 1. So one more point is going to be somewhere here. If I join this, I'm going to get a straight line, so which is passed through the origin. Straight line. So if you draw in the graph, it's going to be a bit accurate, but in the board it's a bit messy. But if you draw in the graph, you're going to get a straight line passing through the origin, making an angle of 45 degree with the x-axis. So this is our identity function. So where y equal to f of x equal to x. Now if you want to find the domain and range, how are we going to find the domain and range? But not, because normally we can't remember everything. Domain r, range r, how are we going to remember everything? So in order to remember this, you're just going to go to the function. So your function is y equal to f of x equal to x. So what are all the possible inputs which you can give here? You can basically put any number on the number line. You can put any number, which means all real numbers could be taken as input here. So our domain, as I told you before, input is r. Now if you put your input as x, so for every x, your y is also going to be exactly equal. So if your domain is x, your range is also going, so if your domain is r, your range is also going to be r, because basically y is equal to x. For every y, you're going to get the same value of x. So input is equal to output. So domain is equal to r, range is equal to r. So this was identity function. The next, move on to the next function. So the next type of function is constant function. So this function is defined as define function from r to r for x belongs to real numbers. We define y equal to f of x equal to c, where c is a constant number. Now the domain and range we're going to find. So let us try to represent this in the form in the graph. So we have the graph again. So this is x-axis, y-axis, 1, 2, 3. So we guys already know that if we have y equal to constant, the equation y equal to constant, the graph is going to look something like a line parallel to x-axis. So this is our line. So this line is equal to y equal to constant. Now here, the point where this parallel line meets the y-axis is basically at the point C. So here it's meeting at 2, so we can say y equal to 2. So this line where it meets the y-axis is basically at the point C. So our C equal to 2. So that's why y equal to 2. So this is the example of a constant function. That's why we call it as constant function, because it is basically constant. Now, what are the possible inputs which you can give here? You can give all the inputs, and for every single inputs, you're going to get your output every single time as that constant number. So your input is, or domain is going to be all real numbers, whereas the range, which is the output you can get, so the output is every single time the constant number, so which is c. So this was about constant function. Now the next type of function is polynomial function. So this is defined as, so define function from r to r for every x belongs to real numbers. We have y equal to f of x equal to a0 x bar 0 plus a1 x bar 1, a2 x bar 2 plus a3 x bar 3, so on, an x bar n. I think you can see a pattern here. So the powers and the subscript is both the same number. So a0 x0, and then it constantly increases all the way up to n. Now your n is all non-negative integers, which is basically starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all those kind of numbers. So those are your n. And next your a1, a2. So these coefficients of x. So coefficient of x is basically all real numbers. So keep this in mind. Your powers of x can only be non-negative integers. Like for example, 0, 1, 2, 3. They can only be these kind of numbers. If there are some fraction, which means they're not valid. They're not valid as a polynomial function. They should always be, the power should always be either 0, 1, 2, 3, 4, 5, 6, all the way up to plus infinity. It should always be a non-negative integers. Whereas this number, the coefficient could be any number. It could be any real number. So the domain and range of this function, it changes from power to power. So for example, you have, if I put n equal to 2, if I put n equal to 2, this function becomes something like this. So f of x a1 x power 1 a2 x power 2. So this is a quadratic equation. So for quadratic equation, the graph is going to be look something like this. So it's a parabola. I can't exactly say what kind of parabola it is, upward or downward. So based on the criteria of what a value is, what a2 value is, the graph changes, and accordingly the domain and range, they keep on changing. So based on the question, based on the criteria, the domain and range adjusts itself. So let us try to solve an example on polynomial function to understand it properly. So the problem is the example 13, define function from r to r by y equal to f of x equal to x square, where x belongs to real numbers. We're supposed to complete this table and find the domain and range of this particular function, which is y equal to f of x equal to x square. So we have this table. So x, they have given all the possible inputs, and we're supposed to find the outputs. So our function is f of x equal to x square. So f of x equal to x square. So first value is 4. So put f of 4, so f of minus 4, my bad. Minus 4 whole square is 16. So this is 16. So we basically have to square the number and write it over here. So that's basically what the function tells. So next is minus 3. So minus 3 whole square, which is 9. So this is 9. Minus 2 whole square, 4. Minus 1 whole square, 1. 0 square, 0. 1 square, 1. 2 square, 4. 9. 16. Now, in order to find domain and range, one of the best ways of finding domain and range is using graphs. So plot this whole x and y in the form of graph, and I'm gonna explain you how you can find domain and range using that. So we have, so 1, 2, 3, minus 20. So this is our y dash. So the first point is minus 4 comma 16. So minus 4 comma 16 somewhere over here, minus 3 comma 9. So minus 3 comma 9 somewhere over here, minus 2 comma 4, minus 2 comma 4 somewhere over here, minus 1 comma 1 somewhere over here. So if you plot this, so 0 comma 0, 0, 1 comma 1 here, 2 plus 2 comma 4 here, 3 comma 9, 3 comma 9, 3 comma 9, 4 comma 16. So if you don't know how to plot a graph, you're in a wrong video. So if you join all these points, you're gonna get this parabola. So basically the graph of this particular function is a parabola. Now based on this, you can find the function. So it's basically extends all the way up to infinity. Now, what are all the values which which covers in the x-axis? So we cover basically all the numbers. You can extend this and still you can find some value in the y. So from this I can say all the values on the number line is my domain. So x is your domain. So always remember x signifies your domain and y signifies your range. So all the possible values of x, you'll get possible values of y. So I can take every single value and put it in this function. So from this I can say the domain of this particular function is, so domain of this particular function, domain equal to set of all real numbers. Set of all real numbers because I can put any real value in this function and it's still going to produce a specific output for me. So that is our domain, and our range is our output. So our output is signified by this y-axis, right? So you can see the values start from 0 and goes all the way to plus infinity. So it starts from 0, goes all the way to plus infinity. So I can say from this, range is 0 comma infinity. So this is our answer. So this is our domain and this is our range. Now let's move on to the next problem. So the next problem is draw the graph function from R to R defined by f of x equal to x cube where x belongs to real number. So let's draw the graph, and you guys probably know the best way of drawing graph is putting the table as we did before. So we're gonna do that. So x, y, f of x equal to x cube. So we're gonna take some random values of x like 0, 1, 2, and here we're gonna take minus 1, minus 2. We're gonna take till minus 3. Okay. Anyway, until here plus 3, and we are supposed to find the possible values of x, possible values of I for every possible values of x. So if x equal to minus 3, your y is going to be f of minus 3 or minus 3 cube, which is minus 27. So the answer for this is minus 27, and y equal to f of minus 2. For this it's going to be minus 2 whole cube, so minus 8. For this is minus 8, and this is minus 1, 0, 1, 8, 27. So this is our possible values. Let us try to plot the graph. So we have our x-axis minus 1, minus 2, minus 3, so minus 30. So now 0 comma 0, so this is our first point. 1 comma 1, so somewhere over here. 2 comma 8, so 2 comma 8, 8 is going to be somewhere over here. And 3 comma 27, 3 comma 27, 27 is somewhere over here, not somewhere over in the middle. Okay, next one is minus 1 comma minus 1 comma minus 1, so it's going to be somewhere here. And next minus 2 comma 8, minus 2 comma 8 somewhere over here. Minus 3 comma 27. Now if you guys use proper graphing, but I do it on the board, it doesn't look much accurate, but if you do it on the graph sheet, it looks beautiful. So if you want to refer how this looks, just refer the Ncert textbook, page number 41, and then minus 3 comma 27, minus 27. So this is our third point. So if you join all these points, it's gonna look something like this. So they just ask us to draw the graph, but we're gonna find the domain and range anyway. So these were the examples of polynomial function, in case you didn't know. So we saw these are polynomials, right? And the examples of these are polynomials. So this is a polynomial function. So we have that graph. So domain, how are we gonna find the domain? So domain is all the possible values in the x-axis. So what possible values of x-axis can we take in this? We can take every single one. So I can say domain is all real numbers. Now range. Now let's see where this curve goes in the y-axis. So it just, you can find values of y in every point on the y-axis, even down below also. So from this I can say range is also set of all real numbers. So this was how you solve this example. Now let us move on to the next function, which is rational function. So the next function is rational function. So rational function are the type of function which is in the form of f of x by g of x, where f of x and g of x are polynomial functions, and g of x is not equal to 0. Now x is defined based on the domain, so this changes from condition to condition. So just forget about this for now. This changes from question to question. So that's why it is given as x defined in a domain. So it is defined in the question normally. So if you want to remember this, you can remember using the definition of rational numbers. So what is rational numbers? Numbers which could be expressed in the form of p by q, where p and q are integers and q should not be equal to 0. Why q is not equal to 0? Because if q becomes 0, what happens? P by 0 is infinity, which is not defined. So we have to take all those kind of numbers. So that's why we define this as not equal to 0. In the exact same way, we define rational function. So f of x by g of x, where f of x and g of x are polynomial functions, and g of x is not equal to 0. So this was rational function. Now let's try to understand this using an example. Example 15. So function defined from r to r minus 0 to r. I'm going to tell you why r minus 0. Defined by f of x equal to 1 by x, where x belongs to r minus 0. We're supposed to find domain range, and we are supposed to complete this table. So let's first complete this table. So f of minus 2. So f of x equal to 1 by x. So if I put f of minus 2, so 1 by minus 2 is going to become minus 0.5. So in the exact same way, if you try to solve the rest of the things, you're going to get this as 0.67. This is minus 1, and this is I think minus 2, this is 4, this is 2, 1, this is again 0.67, and this is 0.5. Now if you represent this in the graph, it's gonna come something like this. So this is our x-axis, this is our y-axis. It's gonna look something like this. So in this side, it's gonna look something like this. So these are x dash, and this is our y dash. So from this graph, you can observe the domain is everything apart from 0, because if you put 0, the y is going to turn to infinity. So our domain is r minus 0. Why? Because if you put x equal to 0, if I put x equal to 0 here, the whole thing is going to turn into infinity. So if I put f of 0, if I do, this becomes 1 by 0, and this becomes infinity, which is not valid. So basically this approaches 0 and y approaches infinity. So that's why that value is not approved. And the next thing is range. We're supposed to find the range. So for range, the range is also the same thing. Why? Because we're never going to obtain the exact value of y. See, if as you get closer to as you put smaller and smaller values of x, the y value is going to become larger and larger. So because of that, the range is also r minus 0. So this was this problem. So let us move on to the next one. So the next type of function, modulus function. So function f r to r defined by f of x equal to mod x. So this is, so we write this two bars, which means you read it as mod x. For each x belongs to real numbers. So this is how the function is defined. So f of x equal to, so if the number what you're putting is positive, you're going to retain as it is. So if it is less than or so greater than or equal to 0, you're going to retain as it is. And if it is a negative number, we're going to convert into a positive number. So the graph is going to look something like this. So if you put, so whatever the value of positive number you put, you're going to get your positive number back. And if it is a negative number, it's going to convert that into a positive number. For example, suppose you have f of minus 3. If you put mod of minus 3, according to the rule, you just have to convert this into positive and write it like this. Because if x is negative, if x is negative, our x is going to convert it to minus of x. In this case, this is minus of 3, which is plus 3. So this is how the modulus function goes, and the graph looks something like this, which is this. The domain is set of all real numbers, because you can see all real numbers, so all values of x could be taken into consideration. So our domain is r, and the range is the y-axis. As I told you to find the range, you should use y-axis. So y-axis covers everything above the origin. So we can take origin and every single number. So x, so 0 So box bracket near the 0 until infinity. So this is modulus function. So the next type of function is signum function. So this function is defined like this: function from R to R defined by f of x equal to 1 if x is positive, it's 0 if x is 0, and if it is minus 1 if x is negative. So this looks in the graph something like this. So y x, if you put any positive value, the answer is going to be 1. So I'm going to put this circle here. So this is our value if x is greater than 0, and if it is 0, this is our value, and if it is negative, it's going to be minus 1. So this is plus 1, this is 0, and this is minus 1. At minus 1, you should exclude this point because that corresponds to 0, and this is all our number line: minus 1, minus 2, minus 3. This is our plus 1, plus 2, plus 3. This is our y-axis, and this is our x-axis. So your domain is, you can put all the values of x. So that's why all real numbers should be taken as domain. The range is, for any value, for any values of x, your output is always going to be 1, 0, or minus 1. It's always going to be 1, 0, or minus 1. That's why the range is 1, 0, and minus 1. So the last type of function is greatest integer function. Now this function is also called as box function. So it is defined as function f r to r defined by f of x equal to box x. So this bracket we write and we call it as box x. We call it as box function. That's why. So greatest integer function or box function. So this assumes the greatest integer less than or equal to x. So let me explain how it works. Suppose if I write f of plus 3.22. So if I put box 3.22, you just have to convert that into the nearest like the integer. Just remove the points and just write the integer, which is 3. So if I write 4.77, if I say f of 4.777, so a box of 4.777, just in the answer remove the points and write it off. So 4. So just assume the greatest integer to this number less than or equal to x. So this is our x. Just assume the greatest integer less than or equal to x. Now the domain is going to be a set of all real numbers, whereas the range is your all integers. So this is the graph. If you plot the graph of this, it's going to look something like this. So this was all the different type of functions. Now let us see the different algebras of functions. So the algebra of real function. So first is addition. So f plus g of x is equal to f of x plus g of x. So just assume you're just multiplying these two with this, and then you get this. So it's not literally, but in order to remember this, just assume x is getting multiplied with this and this. So you get like that. So the next thing is subtraction. So f minus g of x is f of x minus g of x. Next is multiplication with a scalar. So suppose you have an alpha, where alpha is a real number. So if you multiply alpha with f, so alpha f of x equal to, you can take alpha outside, so alpha into f of x. Next one, multiplication with two functions, f g of x equal to f of x into g of x. So this was the fourth one. Next is quotient or division of two functions. So f by g of x equal to f of x divided by g of x. So we have to make sure whether that g of x is not equal to 0, because if it becomes 0, it turns into infinity. So these were the different types of algebra of real function. Now let us try to solve few problems on this to have a better understanding. If f of x equal to x square and g of x equal to 2x plus 1, we're supposed to find all these things. So let's find the first one, which is f plus g of x. So use the formula, which is this into this, this into this. So f of x plus g of x. So what is f of x? F of x is x square, g of x is 2x plus 1. So this is the first answer. Next answer is f minus x, sorry, f minus g of x. So this is f of x minus g of x. So your f of x is x square, whereas minus g of x is 2x plus 1. So if you multiply this minus inside, so it's gonna become this. Next is f into g of x. So f g of x is basically f of x into g of x. So what is f of x? F of x is x squared, g of x is 2x plus 1. So if you multiply this to both internal things, you're going to get something like this. So 2x cube plus 2x square. So this was the third one. So the last one is f by g of x So this is basically f of x divided by g of x. So our f of x is x square, our g of x is 2x plus 1. Now we need to make sure that this doesn't become 0. So when does this become 0? So this shouldn't become 0, right? So when does this become 0? When x equal to So 2x equal to minus 1. So x equal to minus 1 by 2. When this when the value of x becomes minus half, so this becomes 0 and this turns into infinity. So we need to make sure that the value of x is not equal to, so where x is not equal to minus half. So this is the first one. Now let us try to solve one more example. So if f of x equal to root x, g of x equal to x, we're supposed to find the same thing. So first one is f plus g of x. If you know how to solve this, please try to solve and compare with the solution which I give here. So which is f of x plus g of x. So f of x is root x, g of x is x. Next is f minus g of x. So which is f of x minus g of x. So f of x is root x, g of x is minus x. Next is f into g of x. So f of x into g of x. So f of x is root x, g of x is x. Now if you want to further solve this, you can solve it like this. So x is root x is basically x to the power half and x is 1. So this is power 1. So this equals to 1 half plus 1. This is x power 3 by 2. And the next one is f of f by g of x, which is f of x divided by g of x. Now our f of x is square root of x and our g of x is x. As I told you before, you need to make sure that the x doesn't become 0. So I'm going to write x not equal to 0. You can further simplify this also. So our root x is basically x to the power half, and this is x to the power 1. So if this goes up, it becomes something like this: x power half into x power minus 1. If you simplify this, x power minus half. So this was all about the chapter of relations and functions. If you learn something new, make sure to subscribe to my YouTube channel and hit that notification bar. This video takes a lot of time to make, a lot of effort. If my voice is literally gone now, there was so much it takes so much time and effort to do this. So I would like to so if you learn something new, make sure you hit the subscribe button, and I meet you in the next video. Thank you so much for watching.